Hello, today I'm going to talk about how you can 3D model something like this, or this, or this, or this. Something that's way too long to fit into a 3D printer using only 3D printed parts and glue. So to do so, I'll be using Autodesk Fusion since it has a free hobby version. So let's get started. I'll be making an overly simple sword to illustrate the process, but of course you can apply this to any long object. So first I'm just going to create the initial profile of the sword. Finish sketch, and then we can just extrude this out to however long we want it. Then in order to make the crossguard, we can create a sketch down here. Press P to project this surface. O for offset. We can click this and then offset it a little bit. Okay. And then I'll use just a center rectangle to draw this crossguard around it. E for extrude again. Click this, and then we can extrude it out up like that, just as a way to hold it. Click new body so it doesn't attach to the blade. Hit OK. Then we can click on this and hit V to unsee it. Go to our sketches and bring back our second sketch here. Then hit E again for extrude. Bring this crossguard down, and we can join that. Finally, I just create another sketch down here, hit C for circle, and just do something like that. Finish that sketch and extrude it out. There, here's our handle. It may not look proportional, but that's okay. This is just a test. You can, of course, adjust the sizes and stuff to suit whatever you're making. So this, we have just created the first important structural part of the sword. This part right here at the crossguard is the most important part to be structurally sound. This is the place where your hand stops, and therefore, this is the place where the entire weight of the sword is levering down if you hold it sideways out like this. So that's why we've made this super solid connection of this wrapping all the way around the actual blade. So now that we have this rudimentary sword built, it's time for us to slice it up to fit within our printer. Now let's turn the hilt invisible for now, and if you've forgotten how long the blade is, you can click Inspect Measure up here. Click one of the sides, and boom, that's 700. Or alternatively, click this and this point, and we see it's 700 millimeters. So for the sake of demonstration, let's say we're printing this on a Bamboo Lab X1 carbon whose practical print volume is 250 millimeters by 250 millimeters by 250 millimeters. So we know that a 700 millimeter long blade will not fit inside it. So we want to cut this blade up into as few pieces as possible that are still smaller than the build height of the printer that we're using. So this is 700 millimeters, so if we split it into three 240 millimeter parts, it'll fit inside. Of course, your exact numbers may vary. So now that we've decided our length, we can do this neat trick going to modify and change parameters, and we can create a new parameter and call it piece length in millimeters, and we said 240 millimeters. Let's do that right here. Boom. And there's our user parameter up here. So we're going to hit OK. So now we'll construct an offset plane from the base of the blade, and we're going to type in piece length. And then we're going to find out that it's going the wrong direction, so we're going to put a minus sign in front of it. So now it's going the right direction. And then we can do another one, and we can do the same thing here, minus piece length. Again, there we go. So you're going to keep doing this until you've cut your blades in enough pieces as possible. So if we do another offset plane and do minus piece length, you can see it exceeds the length of the blade, so we didn't actually need to do that. And you'll see why in a second. So then we're going to use modify, split body, select this one, and select the first thing as a splitting tool. Theoretically, we could select this one too, but I've found that Fusion glitches out when you sometimes use multiple splitting tools to split the same body. So we're just going to do this twice. Body select, splitting tools here. And now we've got three different pieces. Now, let's take a moment to name all of our pieces. We'll go and turn them all on. We're going to call this blade 3 because it's the farthest one out. This is going to be the hilt. This is going to be blade 1. And this is going to be blade 2. Okay, so now we'll make the part on the very end invisible. And let's do that to this as well. And we're going to create a sketch right here on this plane that we offset. And we're going to press P to project this profile out. Press X to create a construction line, L for line, and draw it here so we know the exact middle. We're going to make sure that our line type is not on construction. We're going to do create polygon, inscribe polygon, click anywhere on the center line, hit tab, and type in 4 to make it to be 4 sides. And we're going to want this to be as big as possible while still giving like a couple millimeters in between the edge so that our 3D printer will actually be able to 3D print it. You'll see specifically why later. So we're going to do that, but we want it to be straight up and down, so we're going to hit L for line, X for construction. We're going to draw a line from the center to the bottom. And then we'll click our horizontal vertical constraint and click this, and that's going to force it to be horizontal, which means that it's going to make sure that this is pointing in all 4 cardinal directions. Now, I'll talk later in the video about exactly why we're doing a diamond shape like this, but for now, all we need to do is make sure that all of our pegs here are the exact same size. So, we want to make another one on the right side, so we want to know exactly how much this line is here. So let's go sketch dimension, and let's just turn it into 7.3 just to make it easier on us. And then we can do the exact same polygon, inscribe polygon, down here, tab 4, boom. And then we draw our line like this and make it vertical. We can use the sketch dimension and click this to make it the exact same as that. So there we go. Now I recommend going to the change parameters, finding this 7.3 that we just did, and favoriting it so we can refer back to it later if we want. Let's call it diamond radius. Okay, and then we can finish sketch. There we go. Now depending on how wide your thing is from like here to here, you might need to draw a lot of these, or more of them at least, but for now, 2 is just fine. So, E for extrude, do both of these, hit symmetric, whole length, and then the distance is going to be our piece length minus 1 millimeter. And I'll show you why in a bit. We're going to change it to new body, and we're going to hit OK. Now, if we go to display settings, visual style, and we can do shaded with hidden edges, it'll show us exactly where these bodies go, and we should see that it goes pretty much almost halfway into this blade 2 here. So next we're going to select rectangular pattern, click these 2 pegs here. As for axes, we're going to click the one pointing in the direction we want, namely along the blade, parallel with it. And then we're going to click 2. We only want 2. We're going to click spacing, and we're going to hit piece length as our length. But we want it to be the opposite direction, so we're going to hit negative. And this way, this puts another set, hit OK, another set of pegs right in the middle of these 2 blade pieces. There we go. Now we're going to send all of these away. Press V so we don't want to view them anymore. And then we're going to make one last peg right in the middle of this blade right here. So we're going to hit sketch, go right here. Polygon, inscribe polygon. 4. Draw our construction line here. Oh, it's exactly vertical already. And then we did save our diamond radius from earlier, so we can just click that, hit enter, and then that will make it the exact same size as the other ones. And then we can extrude and do our symmetric, whole length, piece length, -1, new body. So now we're not going to make any more new bodies. Now, before we proceed, I would like to talk about the Japanese art of pokayoke. It literally means avoiding mistakes, and it basically describes the practice of setting things up in such a way that makes it harder for people to mess it up down the line. So, for example, we made it so that all of our pegs are the exact same size. Now, that's good because it means that we don't have to keep track of which peg is which when we assemble it, because every single peg will fit in any single place that we put it in. Overall, we want to make it as easy to assemble correctly as possible, or rather, we want to make it as difficult as possible to assemble incorrectly, especially if we're uploading it to a model sharing site, say, as part of a 3D model design contest or something. Now, as it is right now, it would be really easy for someone to connect Blade 1 and Blade 3 accidentally, and although Blade 2 is symmetrical in all four ways, they could theoretically, if it wasn't, someone could put it on the wrong way and mess it up that way. So we want to do some things to try and mitigate that. But wait just a moment. We still have to make the holes now, don't we? So in order to do that, let's name all of our new bodies just pegs. Peg 1, peg 2, peg 3, peg 4, peg 5. Now what we can do to make the holes is we can click Combine and select Blade 1 as the target body, and the tool bodies, peg 1, Shift, hold Shift, peg 5. Now we want the operation to be cut, so we're going to use these to cut holes out of this, and we're going to want to keep tools, which means don't make the pegs disappear after we use them to cut. And we're going to hit OK. And we're going to do this for all of the other blades. And the hilt as well. Now, I mentioned earlier that we wanted to put -1 on the piece length for the actual length of the pegs here. And if we didn't put the -1 in there, these two pegs would be touching. And if they were touching, that means the holes would touch, which means that if you put a peg in here, it would slide all the way down, and we really don't want that. We want the pegs to stay where we want them to be, so we add a little backstop in there. So now that we have all the pieces made, we can go ahead and export it, right? Well, wrong. Okay, so the thing about 3D printers is they aren't perfect, so if we try to print it and assemble it as it is now, the parts just simply won't fit together. So we need to make the pegs a little bit smaller. And to do that, we can hide all the parts using our V key, except the pegs. Highlight everything, click press pull, and it goes into offset face. I like to do new offset, take it off of automatic, and do the distance as -0.075 millimeters. That's what I found works for myself on my X1 Carbon and H2D. Your mileage may vary. For me, this difference allows the pegs to fit smoothly into the holes without allowing for too much wiggle room. I've tried 0.05 millimeters of distance before, and while I've made it work for shorter pegs, I've seen longer ones just straight up not fit all the way into their holes due to inconsistencies in the printing process and or friction and or glue. Like, you'll press them in and you'll press so hard you will break the part before you will be able to press the pegs all the way into the proper holes. So next up, we're going to hit press pull, and we're going to select the edges of all of the pegs. Now, one thing you can do if you want to select something that isn't in view, you can hold click on it and then go down, boom, and select it anyway. Boom, 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 boom. And then hit -0.4. Now what this does is it backs off the edges a little bit. Now you can see it's even wider. Like if you go back in time, these are closer. Go forward in time, these are more opened up. And the reason for why we do that is when we print the blades standing up, this part inside the hole will technically be overhang, so it will droop a little bit. So we don't want the droop to encroach on the actual space in the hole and make it too small for the peg to fit in properly. Now the next thing we want to do, select all the pegs, and we'll hit fillet and do it like 1 millimeter or so, maybe even 2 if we're feeling generous. Or maybe, 1.5, and hit OK. Now this does a few things here. It makes it so that imperfections in printing corners won't get in the way of these pegs being inserted in. Also, this allows a way for the air to escape around the pegs if we have a particularly tight fit. And when we print these things laying down, if we have any elephant's foot while printing, which is when your printer kind of squishes out the first few layers, this will help compensate so that layer squish won't interfere with us putting it into the hole. Now there's one tool that we can use in Fusion to make sure we did all of the combining and the hole making correctly, and that's inspect interference. This tool allows you to measure if any bodies are overlapping. So if we just collect the top of this tree here, that'll select the entire thing, and we'll hit this button here, and oh my god, did we forget something? It looks like we forgot something. These pegs and this piece is overlapping. So what can we do? We can go back in time to before we edited the pegs to be a bit smaller, and we can hit combine this, go in here, select all the pegs as the tool bodies, hit OK, go back to the present, and then now if we do our interference again, no interference is detected. Now, if we go back in time a little bit to before we offset the faces of those pegs, we can do inspect interference, select the entire thing, and select this include coincident faces. So it means basically tell me when two things are touching, and compute, and look at all these faces that are touching. And that was before we offset the faces of all the pegs. Now, if we go to the present, inspect everything with it interference. The only three places where two bodies are touching are here and here, which we want, and here, which we'll edit a little bit later, but let's not worry about that for now. One extra thing that we can do if we're really worried about that elephant's foot, where the first layer squish out and therefore any holes in the middle will kind of be squished in and it'll make it harder for us to put the pegs in the hole, we can select chamfer, and we can click on all of the lines around the opening and hit something like 1 or maybe 2 or maybe just 1. And then this will help mitigate any squishing that goes on that might make the hole a little bit smaller. In my experience with my H2D and X1C, we just simply don't need this, so I don't generally do it, but just so you know. Now, bringing that whole Poka-yoke thing up, we're going to do a couple things right now in order to make it very difficult to mess up putting on the wrong way. Or if you do put it on the wrong way, it's very easy to notice right away that you've messed up so you don't accidentally glue something in the incorrect place. Now let's go back in time to before we use a combine tool to make all of these holes. And what we're going to do is V on this, and we're going to use the move tool to select this guy, use translate, that ensures it is only going up and down, left and right, front and back, and move it over like 5 millimeters. And we'll hit OK. And then when we go to the present, we'll see that the holes as well have moved over. So that makes it so the holes have a different orientation depending on what face you're putting together. So it's now impossible for us to do something silly like flipping this around and putting it on the wrong way because the holes won't match up. Now, if you will recall, when we did the inspect interference, including coincident faces, we saw that this entire thing was touching, right? This blade is touching the hilt right here. Now, like I said last time, 3D printers aren't perfect, so it means that we are going to need to back off the inside of this a little bit so that the blade can actually fit in. And again, we're just going to use our press pull tool, select all of the ones in here, and we're actually going to go minus 0.05. Because this is a comparatively short distance, we can get away with it. And now when we do our inspect interference analysis, it only shows these three places touching, which are the only ones that we're okay with. So one last thing with Poka-yoke. Now we made it easy to know which face mates with what face, but we didn't make it easy to know which orientation to put these in. So what I'm going to do is I'm going to create another sketch select it here, take out all the pegs, and right wherever there's space, I'm going to go into text, and I'm just going to click 1. I'm going to make a 1. Just center that a little bit more, and I'm going to hit OK. And then I'm going to finish that sketch, and then I'm going to extrude that one out just a little bit, like 5 millimeters. That's fine. And then combine it with this. This is a target body. This is a tool body. Cut, keep tools like we did before. Now we have a 1, which not only tells us which piece this is, it's blade 1, but it also tells us what orientation it matches up with this blade 2, because blade 2 now has the opposite mirrored image version of a hole of a 1. But again, if we do our interference analysis and we compute it out, these are touching. We don't want that to touch because that'll make it impossible for us to put them together. So what we're going to do is we're going to modify offset face, and then just for these faces, we're going to offset it by -0.3. Now it's all skinny, but it'll fit properly into the blade 2. No problem. You can see that they're offset a little bit. And then we can do the exact same thing here. Now we don't need to do the same thing with like a 0 on the hilt. We could if we wanted to, but it is symmetrical, so it doesn't matter which way you put it in. If you are able to put it in, then it is a correct version. Just, make sure you dry fit everything before. So this is like uber poka-yoke, because not only does it make it more easy to see how to put together, it makes it physically impossible to put together the wrong way, because if you try to take this piece, for example, and put it on here, even if you could, if the pegs lined up, the 1 will not fit into the 2 here, so you will very clearly be able to see that these 2 pieces don't go together. And in general, it's also just handy on making sure that things line up properly. Just, don't glue things before you've dry fitted them, of course. Now, the last thing that I want to do is put everything in their own components. So I'm going to move these guys around and organize them. I'm going to click the hilt, shift click, peg 1, right click, create components from bodies. And then I'm going to shift click all the pegs, right click, move to group. And what's the target group? The target group is peg 1's bodies. Okay. So now everything's in their component, and what this does is when you upload it into Bamboo Studio as a step file, which is what we're about to do, it will separate all of these into their own specific part in Bamboo Studio, and you'll see what I mean. So now our modeling is all finished, so we can export. Now make sure you export it as a step file. Boom, and we'll save it and export it, and now we can open up Bamboo Studio to continue on from here. So let's just drag and drop our step file into Bamboo Studio. We can hit OK, and we can use the rotate tool to orient it like this, -90, I guess. Split to objects tool up here, and what does that do? Splits everything to objects, including, we can just move our pegs out of the way there. We can use the auto arrange tool here to arrange them so that they're not touching. And then we can use the rotate tool to rotate it 45 degrees like that, 90 degrees like that. We can split it to objects, drag everything on the plate, use auto arrange, boom. And so now we've got all of our pieces together. Now you might want to rearrange them depending on what color you want to print them out in, but let's just keep them all in white for now so they're easy to see. Now these guys don't need any supports, so they're fine. The hilt does need supports. Let's go into its object settings and turn on support. If we preview this, we can see it's got supports, but one problem it's got is the supports run all the way up into the top. And that's going to be a pain to remove, and if it breaks off in there, we might not be able to. So when we go into our preparation one, we need to choose Paint Supports, and then right-click to paint blockers here. And what these blockers do is they say, hey, it doesn't matter if supports is turned on, do not use supports on this. Exit out of that. Oh, and then we realize that these 1 and 2 are the wrong way around, so we could use our turn on face to flip them over Let's just flip them all over. And then now we can see it's automatically provided brims for us, which is good. This is properly supported, but there are no supports running up the center here, which is exactly what we want. Now, the last settings you want to do before printing is to turn all of the infill for the blade pieces, the pieces that will be extended out that you will not be holding, to 5%. And all of the pegs and all of the hilt pieces, aka the ones you will be holding, the ones that will be supporting thing, go up to 20. I'll explain more in depth in a sec, but the long story short is we want the blades to be as light as possible because we don't want gravity wrenching down and levering on the hilt, but we want the hilt and the pegs to be as strong as possible because they're bearing the brunt of the force. One thing before I hit print. The reason that I said to use diamonds is because they can be printed supportless no matter what orientation they're in. Even if we print something like this, it still won't need supports because of the diamond shape. So if you want to make something that is too tall to put on the build plate and too wide, you can put these diamond shaped holes in the side and not have to worry about pulling support materials out of deep holes or worry about tolerances due to scarring due to support interfaces. So after you've done all this, you can slice it up and hit print. And when you do, it'll look something like
this. Now, admittedly, this is not the exact same model you saw me make in the tutorial. I made it so that all the parts are swap-outable because I felt like it. But as you can see, even without glue, I can hold it out like this just fine. It's just the thing is that adding glue makes it so that, you know, this doesn't happen. So now that we've gotten all this done, the final question is, why did we need to print this out so that the pegs were laying down, but the blades were standing up?
Well, to demonstrate that, I printed out 2 pegs and 2 holes. They're the exact same shape, except that the red ones were printed laying down and the black ones were printed standing up, which changes the direction the layer lines are facing. Now, if we bend the pegs like this, simulating gravity pulling down on them, we see that the black one snaps cleanly along the layer lines, but the red one just bends a bit. But for the holes, I stuck a pair of pliers inside and tried my best to open them, simulating a peg pressing outwards. This time, the red one splits open, but the black one completely resists my attempts to break it. So, as we saw, we want the black hole, but the red peg. E.g., we want the pegs printed lying down, and the pieces with the holes in them printed standing up.
And that's that. The only thing I have left to say about this process is that while I know it is good enough, it might not be perfectly optimized. I've used it multiple times to great effect. However, it could be made stronger and or lighter by doing things like reducing the infill but increasing the number of wall loops, changing the distance the pegs' faces are offset by, or even changing the lengths of the pegs themselves. All those things could make it much better. However, I'm not CNC Kitchen and I don't really have the facilities or resources to print out full-length trials of all of those different things to try to figure out which one is the best. So if you want to see this method taken to its absolute extreme, I will unfortunately have to let the testing be done by someone else who does. So if that is you, by all means, hit me up. I would love to chat. But for real this time, video over. Thank you for watching till the end. If you'd like to print this out, you can check that out in the links in the description. And of course, don't forget to subscribe. I'll see you next time. Bye.